This is the last presentation of Module 2. Please view the other 3 presentations before viewing the current presentation. In this presentation, we measure and interpret data on gender equality in education using gender-sensitive indicators. More specifically, upon completion of viewing this presentation, you will be in a position to interpret a set of indicators and visual aids to describe gender equality in education. Make policy suggestions to address gender inequality based on the interpretations. Please note that in order to correctly interpret the results, it is important to take time to review the technical implication of each indicator. As you may remember, according to the UNESCO's definition, gender equality means that boys and girls would experience the same advantages and disadvantages in going to school, enjoying teaching method, curricula, and academic orientation, and producing equal learning achievement and subsequent life opportunities. The question is how we shall measure these different concepts embedded in gender equality in education. Based on the following table, what indicators should be used in order to describe the reduction in gender disparity, and why? As we have seen in the previous presentation, 2 measures of disparities are often used in comparing educational indicators. The first one is the gender gap. It is the difference between male and female rates, but the male's rate minus the female's rate, which is expressed in percentage points. Therefore, a positive gender gap indicates the disparity in favor of males, and the negative gap would signify a disparity in favor of females. The other measure is the gender parity index. It is a ratio between the females and the males' rates. More specifically, females' rate divided by the males' rate. GPI of 1 means the parity, where the male and female indicators are exactly equal. If GPI is below 1, the disparity is in favor of males, and if GPI is above 1, the disparity is in favor of females. Let us see an example. In 1990, the number of intake for boys and girls were equal, and in 2005, the girls' intake was higher than the boys' intake, but the GPI values were below 1, indicating that boys were in favor. Why is it possible? This is because the girls' population was higher than the boys' population in these years. Please note that GPI is not comparing the raw numbers, but comparing the rates calculated for boys and girls. Another important feature is that a high GPI value could be generated with very low intake rates, as seen in the year 1990. Now stop the video while you interpret the GPI of 1.11 generated in 2010. This graph is called a scatter diagram. It shows the girls' intake rate on the x-axis and the boys' intake rate on the y-axis. The dots are shown where the values on the x-axis and y-axis cross. The parity line is shown by a diagonal line which goes through the equal values of x and y. The parity line is different from the trend line, which is the closest possible line from all the dots. The data point for 2010 appears below the parity line because the intake rate was in favor of girls in 2010. Stop the video and interpret the other data points. This scatter diagram shows the survival rate to grade 5, which is measured by the percentage of pupils out of the cohort that entered into grade 1. We previously saw that the access was in favor of boys, but here girls favor in survival rates. Therefore, in this example, we can interpret that once girls enter into school, they abandon schools less than boys. You may also measure the gender disparity in the learning achievements as well as longer-term outcomes. Please note that the base of comparison is different for each indicator. For example, while the intake rate uses the population as the base, the survival rate and the completion rate use the cohort that entered into the first grade. To check each formula, please see the relevant documents in the formula toolbox of the platform. Odd ratios measure the comparative advantage of individuals belonging to one group to another, for example, boys to girls, in achieving a higher outcome rather than a poorer outcome, expressed in indicators. For each group, the odd can be calculated comparing the higher outcome against the poorer outcome. Here, the male student's odd for starting the tertiary level compared to completing the secondary is 0.8, while the odd for female student is 0.67. Therefore, the probability of starting the tertiary level rather than completing the secondary level for the male students is 1.2 times higher than that for the female students. You may wish to try the odd ratio analysis using the data from your country. The gender disparity may vary depending on other variables such as school location and the socioeconomic status. For example, UNESCO Global Education Monitoring Report illustrates that in Cameroon, the gender disparity on the upper secondary completion rate in the rural area is very small, where both boys and girls have very low percentages, while in the urban area there is a larger gender disparity in favor of boys. Stop the video to check the situation of your country in the World Inequality Database, which is available in the database toolbox of the platform. The unit cost is the total expenditure incurred by the education system to produce one graduate, which is based on all fixed cost and recurrent cost. The marginal cost is the additional cost by producing one extra graduate. Does it cost the same for educating a girl and a boy? What kind of cost could be different between girls and boys? Stop the video and reflect on these questions. Let us use the Lorenz curve to study the equity by comparing the relative shares of boys and girls' enrollment rate and their unit cost. The cumulative share of the enrollment rates is shown on the x-axis, and the cumulative share of the unit cost is shown on the y-axis. The parity line connects the theoretical values where the cumulative proportions of enrollment rates and the unit cost are equal between boys and girls. The curve which connects the actual cumulative shares in these indicators is referred to as the Lorenz curve. The area generated by the parity line and the Lorenz curve is referred to as Gini coefficient. The larger the area, the larger the inequity. The degree of inequity could be different depending on the geographical location, socioeconomic status, and the education cycle. In this example, 7 indices of a scale 1 to 5, combining the participation, achievement, staffing, and school environment have been selected to be plotted on a spider web. The green line at the value of 3 indicates the gender equality, and the values of 1 and 5 are the larger gender disparities in two opposite directions. If an indicator shows a disparity in favor of girls and females, it would appear outside the equality line. If an indicator shows a disparity in favor of boys and males, it would appear inside the equality line. For Botswana, the situation during the year 2000 in blue line shows that most of the indicators were located outside the equality line, illustrating that girls and females are in favor. The only exception was the toilet ratio, which had no disparity. When comparing the situation in the year 2007, not much has been changed, except for the female proportion of the school heads, which further increased. The situation for Mozambique was completely different. Stop the video and write down your interpretations for Mozambique by comparing the years 2000 and 2007. Here are some selected indicators including girls' achievement and their learning environment. It illustrates that girls in countries A, B, and C had higher mathematics scores than countries D and E. When examining the computer availability, girls in the high-achieving countries had lower percentages than the lower-achieving countries. When it comes to the proportion of female teachers, the lower-achieving countries yielded higher proportions for the female teachers. Finally, the girls' engagement was higher in the low-achieving countries. What is your policy suggestion? You may think the government should make major reductions in the national education budget, because there is no need to equip schools with computers, no need to plan the in-service training to increase female mathematics teachers, and no need to revise the mathematics curriculum to attract girls' interest. Do you agree with this policy suggestion? In fact, in this policy suggestion, we are assuming that the relationship established at the cross-country level can be also seen at the more disaggregated level, such as a school level, which may not be the case. In addition, there may be other indicators that are not shown here that could be more strongly related to the girls' mathematics achievement. Here are 3 short exercises that you may complete in order to identify your national indicators of gender disparities. These exercises will also be useful when preparing for your group project. In order to keep track of the Agenda 2030, it is not enough to report on the sex disaggregated indicators on access and participation, but also to complement with gender-sensitive statistics and indicators on the process at the school and the learning outcomes. When interpreting these indicators, it is critical to understand the basis of calculation because different indicators have different comparison points. Your interpretation may take a different angle when you cross gender with other variables such as school location, socioeconomic status, and so on. Finally, the aggregated indicators may not provide the same message on the relationship between them if different unit of analysis was considered. Careful interpretations and further analysis, including more qualitative analysis, may be necessary. This is the final presentation for Module 2. At this time, you may continue building the collaborative glossary based on the new concept that you have learned during Module 2. In addition, if you have not yet participated in the controversy forum, please do so. Finally, you should be able to work on the group project, Section 2.